Hi, Assalamualaikum. So I'm Wazir. So today I'm going to be presenting about my first assignment, which has the topic of 18th century Semaphore telegraph system by Claude Chep. So a semaphore system is a communication system that uses primarily the visual signals to transfer information over long distances. So things that were commonly used as part of the semaphore system are things like fire, light, sunlight, moving arms, and flags. So these are the things that can be easily seen over very long distances. So a guy called Claude Chep, who was a French engineer, during the French Revolution invented the first semaphore telegraph lines in France, and this line connected Paris and Lille. And this line was invented to accommodate or to meet the demand of the military communication during the French Revolution. So in the 1790, he finalized the design of the semaphore telegraph line, especially the tower. So for the relay tower, it consisted of two sets of wooden beams, and one is the main beam called regulator, which has a length of around 4 meters, and attached to the regulator are two smaller wooden arms called indicators, and they were both painted in black so that we can contrast them with the color of the sky to ensure visibility. Okay, so as you can see here, this is the design of the relay tower by Claude Chep. So you can see the main beam, which is the regulator, and you can also see the smaller wooden arms, which are the indicators, and these beams are manipulated by the operator using wires to create a bunch of symbols. So you can see here, the design of the tower can create up to 92 different symbols, and it enables the operators to translate up to 8,464 different words and phrases using the 92 symbols codebook developed by Claude and his brother. Okay. So a typical relay tower for the telegraph line consists of three different operators. So the first operator has a job which is to watch and record the signal from the adjacent tower using the telescope. Okay, and the second operator would then adjust the regulator and the indicator to indicate the current symbol. Okay, so and then we have the third operator, which acts as a checker to ensure that information transmitted are accurate. So the transmission process consists of two steps. The first step is setup, and the second step is completion. So in the setup process, we have two movements. So the first movement is that the indicator arm would be adjusted to align with the regulator to form a non-signal as a starting point. And the next step, the second movement, okay, the regulator and indicator arms will then move in a position to indicate the current symbol, and then the operator would then wait for the symbols to be copied by the downline operator. Okay, so the last step is the third movement in the completion step. So after the regulator, the operator downline successfully copied the symbol, the regulators and the indicators will then adjust it back to the original position, whether it's horizontal or position or vertical, to indicate the end of the cycle. So at the end of the transmission line, we have the decoders, and they were the ones who would collect the signals and symbols and then recompose them back into the original message, and the message would then be sent to the administrator. So the success of the semaphore telegraph line enabled the transmission rate to be around 3 symbols per minute, and the line from Paris to Lille spans around 230 kilometers, and it only took them around 10 minutes to transmit the signal on average. So lessons learned from research is that whenever we find problems with current technologies, we should always think that it is an opportunity for us to innovate. Okay, and sometimes creative thinking and thinking out of the box enables us to invent a completely new novel technology. So new technologies do not exist in isolation. It always requires years or even centuries of effort from innovators and scientists and different sectors of society in order to for it to be successful. Thank you.